Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Manager of Dataversity. We would like to thank you for attending Dataversity Demo Day, Enterprise Data Management Tools. We're very excited to have you join us for this event. We have a great lineup of sessions for you today to give you an overview of tools and products available for your data management programs. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the event. For questions, we will have a Q&A at the end of each presentation today, and we will be collecting questions via the Q&A in the bottom right-hand corner of your screen, or if you like to tweet, we encourage you to share highlights or questions via Twitter using hashtag #DVDemoDay. And for this event, we will send a follow-up email within the next week to all registrants containing links to the recordings and slides from today's presentations. And if you'd like to chat with us and with each other, we certainly encourage you to do so. Just click the chat icon in the bottom right-hand corner for that feature. Now let's kick off our second session with Hacklite, and let me introduce our speaker, Pascal Desmarais. Pascal leads Hacklite and all efforts involving business strategy, product innovation, and customer relations as it focuses on producing user-friendly, powerful visual tools to smooth onboarding of NoSQL technology in enterprise IT landscapes. And with that, I will give the floor to Pascal to get this session started. Hello and welcome.
Thank you, Shannon, and hello, everyone. Thank you for attending our session on model-driven API generation. Today, we will discuss and demonstrate a feature of our software to generate REST APIs from data models, from database models also. An approach that will greatly increase API quality and consistency and reduce your total cost of ownership. The session is divided in 3 parts: a slide presentation followed by a demo of the functionality, and finally a few minutes to answer questions you might have. Feel free to pose them, as Shannon said, in the Q&A section, and we'll answer them at the end. For those of you who don't know us, Hacklite is a different kind of data modeling tool. We're not positioned to compete with the existing entity relationship diagram tools of the market, but rather to complement them by doing things that are particularly difficult for those tools, as they were originally designed to only deal with relational databases, that is, with flat structures. Hacklite, a unique advantage is to be able to natively handle hierarchical structures with deeply nested objects and the polymorphism found in big data, NoSQL, and JSON. We can also perform data modeling for property graph databases, such as Neo4j and Gremlin-based graph databases. And finally, we're able to apply our technology to a schema-centric visual design of REST APIs. We will come back to this in the rest of the session. Traditional data modeling entity relationship software can just generate DDLs for relational databases in SQL syntax. Hacklite can do that too, but is specialized in the schema design and generation of scripts in the variety of languages and syntax found in all of the NoSQL databases and protocols we support. In the picture here, you've got MongoDB, Neo4j, and Avro, but we deal with many others. As you can see from this slide, we support a number of modern technologies for data at rest as well as data in motion. And if you store JSON in relational databases, you'll be interested to know that we can infer the schema of JSON documents during our reverse engineering of RDBMS, which is not something that shows up in DDLs. And we can, of course, do the schema design of JSON structures in a forward engineering use case. Now let's talk about the main subject of today's session. APIs are useful because they connect different applications or services together. APIs are the basis of every digital strategy. There's some hype, of course, about digital platforms, but application leaders must not lose sight of the fact that the most essential basic elements of digital business platforms are application programming interfaces. APIs make digital society and digital business work by connecting people, businesses, and things. Those connections enable new digital products and business models and create new business channels. A REST API lets a client communicate with a server to extract the required information to operate a function. The client makes a request to the server for the required information via an API, and then the server responds, sends the responses to the client. The data is returned in form of a structured format, either JSON or XML, but more generally JSON these days. There are different solutions that exist to communicate or document APIs. Some are more user-friendly, others are more developer-friendly. One of the most popular solutions is Swagger, which has evolved into a widely adopted open source specification called OpenAPI, or OAS, in its latest version 3. When it comes to developing applications, particularly with the advent of agile development and so-called schema-less NoSQL databases, we have seen some trends where application code is sometimes developed first in a quick and dirty or fail-fast approach. Then the APIs are defined afterwards. Then there is a cycle of improving the application, refining the data model, etc. While this may work for a small and early prototype to be thrown away after proof of concept, this is not really a scalable approach for larger applications, and certainly not one that is very efficient. And some people may call this agile, but in fact, it's really a fake interpretation of agile principles. A better approach is called API first. You start by designing and building APIs, then creating the rest of an application around them. This allows the team and any of the other stakeholders to weigh in on the proposed direction and functionality, and they can do this early and often. So gathering the feedback of this early stage allows you to make easier changes before a lot of time and effort is sunk into the project. It makes the project more accessible to both technical and non-technical team members. So you can see that this process is already better aligned with the agile development principles of iterating rapidly. But then there's a next step, which is what's called design first approach. You don't just first design the API, you also design the whole application, its underlying data model, and you ensure that it will all work well together. Development teams can work in parallel thanks to this, because you create the contract between the services across an organization. This allows the teams to work on multiple APIs at the same time and to have API development and application development done in parallel. So this approach obviously increases the speed to market. It ensures a good developer experience because well-designed, well-documented, consistent APIs provide positive developer experiences, and it's easier to reuse the code and onboard developers and reduce the learning curve. So in the end, this approach reduces the risk of failure by ensuring that APIs are reliable, consistent, and easy for developers to use. But don't get me wrong, with a model-driven API generation, we're not suggesting that you should expose your entire storage data model to consumers. Design in particular to leverage NoSQL technology should be centered around the application-specific access patterns. It should be query-driven. The idea is not to expose, like I said, the storage implementation details to outside consumers, but to clearly define and document the data exchange contract. In other words, the schema of the information being requested and returned in an approach called CQRS, which stands for Command Query Responsibility Segregation. You can use different models to update the information than the model you use to read the information, and both of them being different than the model used to store the information. So to design and maintain and document these APIs, Hacklite software provides a schema-centric graphical view so the teams can have a conversation around the critical structure of the information being exchanged. Hacklite takes the graphically designed API and automatically generates the syntactically correct definition in JSON or YAML without requiring any programming knowledge. And you can easily integrate this into your existing API creation process as we generate perfectly compliant Swagger or OpenAPI files. So now that we've set the context, let me introduce our model-driven API generation feature before I get into the hands-on demo. It's a three-step process. You take a data model, and it can be tables or views for a relational database, or it could be denormalized NoSQL structures, or Avro schema for Kafka, or Parquet schema for a data lake. That's the first step. In a second step, you select a standard API template for your company. You may have multiple templates for different API profiles, but you need to pick one template in this second step. And finally, you get the API generated by Hacklite on the basis of the previous two steps. You may do some editing before you finalize it, and you can insert it into your process. So now let me switch to a hands-on demo of the tool of our solution. So we have seen that Hacklite supports a variety of technologies. This is done through open source plugins which can be downloaded from GitHub. But you should only download the plugins for the technologies that interest you, of course. If you want to generate APIs from models, the feature we're demoing today, you also need the plugin for either Swagger version 2 or OpenAPI version 3. And also, please note that some of the plugins here are still beta versions, in particular the Oracle Apache ORC and the Swagger, and the Redshift plugin. So for today's demo, we will work from a MongoDB model, but you can easily transpose what you'll see to other technologies that we support. You may create a data model from scratch, and starting from a blank page and creating your model for forward engineering. But I'm opening here an existing model. The famous Northwind database relational model that was imported from an Oracle DDL. Just to point out, with Hacklite, you may import models from a variety of sources, JSON document, JSON schema, DDLs from a variety of dialects, XSD from other data modeling tools, and Microsoft Excel also. Plus, of course, you may reverse engineer from database instances. for the chosen target technology. Typically, with NoSQL databases being schemaless, they don't support the concepts of DDLs, so we infer the schema from sampling JSON documents in the database instance. So the tool includes many features you'd expect from a data modeling software beyond building an entity relationship diagram. So for example, we have the ability to maintain business names and technical names. We have the possibility to define structures once in a library, then reuse those structures in many different places. And even we have a command line interface to schedule tasks and integrate with a Jenkins CI/CD pipeline, et cetera, et cetera. Let me show you how the tool can also easily help you denormalize a flat relational model like we have here to something that is more appropriate for NoSQL. So as I mentioned earlier, for NoSQL, you don't want to create a generic or application agnostic data model like we've been taught to do with the rules of normalization. Instead, you want to first identify and analyze the access patterns of your application and design a schema that is specific to this application. So you do what's called a query-driven schema design. And to do this, we have some denormalization features to help you with this migration. So in this particular case, we're going to take, you see here, an orders table and an order details table, which we want to combine into a single collection of documents. So with just a few clicks, we can combine these two structures. I'm going to select orders and order details. And as a modeler, I know that I want to combine order details within the parent table orders. And I do this, and now I no longer need this order details table because it's been embedded here. And as a next step, I draw a foreign key relationship to the products table, and I repeat the function, this time combining orders and products table as a subdocument in the child. And so now this integration has been done, but there are some attributes here that are really not needed in the denormalization because they belong more to a master table. And so here we've done it very quickly. We have denormalized the model into something that is better suited to NoSQL document databases. A modeler would want to enrich this model with descriptions and constraints, and from this model we can produce several different artifacts. One of them is an HTML clickable documentation of the whole model with all of the pictures and metadata and everything that's been defined in the application. We can also go and generate a JSON schema structure for this, for whatever model has been defined in Hacklite, plus a sample JSON document. And we can also forward engineer some scripts. In this case, because we're in a MongoDB model, we generate the MongoDB validator syntax in JSON schema without requiring any knowledge of building a JSON schema. And so those are some of the artifacts that we're able to produce with the application. And so we will see a little bit later how from this model we will be able to generate an API for this. Okay, so let's take a look now at our support for REST APIs in general. So as I mentioned earlier, we take a schema-centric and visual approach to API design. What we mean with schema-centric is that the essence, really the core of an API, is the contract that is being exchanged between the producer and the consumer of this API. If we don't agree on the structure and the meaning of the data that's being exchanged, well, the protocol does not matter very much. So if we want to have a conversation with the different application stakeholders about the API, the most important stuff to be discussed is about the information being passed around and how to best structure it in order to satisfy the use case. The alternative with the tools that are available from the producers of Swagger and OpenAPI is this editor where a developer who's very familiar with the syntax can code on the left-hand side all of the necessary stuff to generate the API, which is then produced on the right-hand side when all of the commas and quotes are in the right place. And this is a riskier or more cumbersome way of creating an API. And if anything, if there's a mistake anywhere, well, nothing's working and you cannot see the results until all of it has been finished. So at Hacklite, we take the opposite approach. You create the structure and then fill in the form that appears on the right-hand side. You fill in the blanks where needed, and from that we generate the API automatically without having to know the syntax. So with this pet store model, which is the famous example used in Swagger and OpenAPI examples, you can see that there's a components section for schemas where you can define the structure once, and this structure, once it's been defined, can be referenced and reused elsewhere in the API in many different places without having to redefine things. And so we had in the components section, several entities that were created. Here, a user, tag, pet. And so if we go to a transaction of the API that is defined, in this particular case, the 200 response to a GET request, the definition of the pet structure is referenced here without having to redefine it again and again. And so you can see that the user can easily quickly build the API based on that structure, fill in the form, as I said, on the right-hand side, and then click one button, and the whole API definition file in the proper syntax for OpenAPI gets automatically generated, either in JSON or in YAML format. So, and you can also interact with the API on the right-hand side before you copy and paste this into your API ecosystem and process, or you use our command line interface to generate this automatically and include it in your automated processes. So that was how you would maybe start an API from scratch or reverse engineer existing APIs for documentation. But the purpose of this demo is to show you how you can create an API automatically from an existing system, from an existing model, really. So we saw in the first step how you could create your data model. And then the second step, as I mentioned, is to use a template that has been defined. We provide a base template that you can use as is, or that you can modify and evolve to respond to your exact needs. In this template, we have placeholders, which will be used by the application when merging with the data model created in step one. So if we go again to the components schema section, you see a structure called entity, and this entity will be replaced by each instance of an entity table or collection in the original model. So also defined are placeholders for all of the responses with their structures and the requests. So you can see here how each of the CRUD resources, so we have a post for create, a get for read, a put for update, and a delete transaction. All of this is defined in the API with the structure of the corresponding responses for each of these requests. So if I go back again to the original model, I failed to mention, or I want to insist again. So this is the base API template, and you can go ahead and modify this, putting in your endpoints and your contact information in the metadata, and modifying the responses to best suit your needs. And you may have multiple templates as well, if for different profiles of APIs. So if I go back to the original model, it's very easy to generate an API. You go to Tools, Forward Engineering, API Model. You choose between OpenAPI or Swagger, and you now have a list of all your entities. Like I mentioned, we're going to just take orders, products, and customers, and then here you can select the API template to be used to generate this. In the interest of time, I'll go straight to the end result. Okay, so let's take a look here. We had selected 3 tables in the original model. So in the components schema section, we will find, besides the error definitions here for the API, that we've created an entity for customers, an entity for orders, and an entity for products. And if you take a look at them, the whole structure that had been defined in the model earlier today when we did the denormalization, all of this is present here, has been passed to this API definition. So all of this, these entities have been created in the components schema section. And then the application performed the what we called the cardinal product of all the selected entities of the original model by the resources defined in the template. So in the template, we had 2 resources for a total of 4 requests for the CRUD. And so that gives us 6 resources. And all of this was then produced automatically. And you see how in the 200 response of the GET request, the whole structure that had been defined in the data model has been carried on over here. And now, after doing some editing maybe of the metadata, you just click on one button here, and it generates the entire API definition for this model that had been created originally. So that's about it for the demo. I need to go back to the screen and recap here what happened. The step 1, you open or you create a hacklite model. You select the entities for which you want to generate the API. You select a predefined template, as I showed in the demo, and then you get the entire OpenAPI definition that can be integrated into your API process. And you also get a model in which you can make all your edits. So that wraps up the demo part of this presentation. So Hacklite is natively designed to handle hierarchical structures that you find in modern technology these days. It supports data at rest and data in motion. And when you define structures once, you can then use this feature of model-driven API generation to increase the quality and the consistency of your APIs. And there's a lot more information that can be found in our online help. So with this, I let you, Shannon, maybe collect the Q&A that were posted during the demo.
Indeed. Pascal, thank you so much for this session. And if you have questions, feel free to submit them in the Q&A section in the bottom right-hand corner of your screen. So diving in here, can you use a data model developed in Archimet?
I'm not familiar with the brand you just named, but if that tool can generate an XSD or a DDL, it can be imported into Hacklite, into a Hacklite model, and then generate the API from it.
And is the error status code and corresponding messages, are they inbuilt?
No, so we created them in the API, with our knowledge of APIs, and all of those can be user-defined. You can start from the template that we defined and make that template evolve to your exact needs.
And what's the purpose of generating Swagger API versus OpenAPI?
Okay, so Swagger is version 2. Swagger was sponsored by a company called SmartBear, and then they made it evolve, and they made it open source, and it became it was rebranded as OpenAPI with version 3. So OpenAPI is a better, richer version of Swagger 2. Some companies that were early adopters of Swagger may still be in version 2, but there are steps to evolve towards version 3, which is called OpenAPI, and that's what I would recommend if you're starting.
And can I import the data model from any open source tool?
Provided that that open source tool can export to DDL, XSD, JSON schema, map it to Excel. Yeah, we can import from a number of sources, but maybe not from all of them.
I love it. So is there any evaluation version for the proof of concept work?
Yes, absolutely. So if you go to our website, we have a standard 14-day free trial with the full functionality. And if you need more time for your evaluation, you shoot us an email at support@hacklite.com, and we're happy to accommodate reasonable requests for a longer evaluation period, of course. But with the 14-day free trial, you have all of the features of the product for that length of time.
And in which format is the API exported?
So we persist models, whether they're data, the standard data models or the models for OpenAPI. We persist this simply in JSON, but we can forward engineer. If it's an OpenAPI model, we can forward engineer in OpenAPI format would be JSON or YAML. We can also export to JSON schema, and if you have models for other targets like MongoDB, we're going to be able to to forward engineer to Mongoose or MongoDB script. If you're in Cassandra, we'll generate CQL script. If you're in Hive, we'll export HQL script, etc., etc. So for each of the different targets, we're able to speak the language of that technology platform.
And Pascal, does Hacklite support, does Hacklite handle semantic synonyms between tables? For example, the equivalent meaning of differently named labels and ontologies?
So let me be careful about this. So you can create user-defined properties in Hacklite where you can store all kinds of different things. So if the properties that are available currently don't satisfy your needs for different aliases or other things you might want to do, you can create these user-defined properties, and that gets carried through all of the functionality of the tool and can be exported to documentation, Excel, and all of those things. When it comes to support of semantic web, we are on the path to doing that. I listed in a slide the different technologies we support, and we are on the roadmap to support all of the families of NoSQL databases. Currently, the work for RDF, semantic knowledge graph, Shackle, OWL, and all of this is work in progress, and we're almost there, but not quite there yet.
Does Hacklite support connector to integrate with API GEE and API management tool to register the APIs? I know that Hacklite can connect to GitHub for version management.
Yeah, so we haven't done those connectors yet, but this is something to be investigated, particularly since our command line interface is available, to run inside scripts. It's fairly easy to go ahead and post an artifact that's been outputted by the application and go ahead and post it to some of the API platforms that exist.
And how does your licensing model work?
So we have either perpetual license with the traditional annual maintenance, or we have subscriptions, and we have monthly and yearly subscriptions. All of this can be done self-service via our e-commerce platform, or for larger companies, you can deal direct with us with purchase orders and an invoicing process, or through resellers that are listed on our website on the references page.
And you've kind of touched on this already, but I'll ask it again just for clarification. Does hacklite import the API data model and its data, or create them in the source?
So we can definitely reverse engineer or import existing API definitions in Swagger or OpenAPI formats. If you don't have one of those two formats, you may have a JSON document that represents the structure, or even a JSON schema that represents the structure, and we can import all of that in Hacklite to build the proper API documentation. Hopefully that's clearer and answers the question.
Sure, definitely ask for additional comments there if the questioner wants to expand. And I noticed you have plugins for MS SQL Server and Beta for Oracle. Are you moving into the traditional relational database modeling market?
Yeah, that's a good question. Actually, yes and no. We don't want to compete with Irwin and Power Designer and Infosphere, ER Studio, Architect, and all of those. Those are great tools. We tremendously respect them. I've used them for decades myself. We just want to complement them. So we are able to handle relational databases, but I explained earlier that is specifically for the purpose of the added value we can provide with the ability we have of reverse engineering JSON structures that might be stored in varchar max or blobs, etc. Because we have this ability that we've developed with our support of MongoDB and other NoSQL databases to have developed a schema inference engine that is very feature-rich and very aware of all of the polymorphism you might find in JSON. And so we've applied this knowledge and this expertise to RDBMS, relational databases, at the request of our customers who are running a mix of relational and NoSQL, and so they saw us shine on the NoSQL side, and they asked us to be able to do that if they store JSON in relational databases. But we're really not positioning ourselves as an alternative to the traditional tools. Most of our customers, Fortune 500 and US government agencies, are users of the traditional the traditional data modeling tools. They're not giving them up, but they purchase Hacklite as a complement so we can cover the rest of the technology that's being handled by these customers.
I think we have time for at least one more question here. So can the taxonomies be generated along with the API, aka data package specification?
I don't understand totally the context of the question. If that can be made more precise, or we can take this offline.
Sure. Yeah, no problem. So I'll ask the questioner if you want to rephrase that a little bit. And while you're doing that, is Hacklite API generation like Visual Studio or Eclipse IDE functions? So
I'm not personally familiar with them. I'm not a developer myself, but we take a very different approach from any tools that are out there in the sense that we have this truly graphical approach to the structure building. But then afterwards, we want to integrate completely in existing processes. We're not there to compete and make you have to re-engineer your API development process. We want to plug into it and just facilitate the work of developing the API and make it a more reliable process, both on the business side, because the application stakeholders understand the structure that is being exchanged, and on the technical side, because our tool has a built-in validator and will not allow the creation of an open API or Swagger definition that does not syntactically respect the specification of those definitions.
Well, Pascal, thank you so much, and thanks to Hacklite for this great presentation, but I'm afraid that is all the time we have slotted for this session. Thanks to all the attendees who have joined us so far. We now have a 15-minute break where we encourage you to network with each other as you hear us get the next speaker set up. The next session will begin at the top of the hour where we will hear Andrew Goad from DataStax present using Astra to speed app delivery. Pascal, thank you so much. A great presentation as always. Really appreciate it.
Thank you, Shannon, and thank you everyone for attending. Bye-bye.